We are going to be talking about polygons. Now, in order to understand a polygon, you need to understand that the number of sides that a shape has determines the name of that polygon. The number of sides also determines the number of angles. So, for example, if we have a shape with 3 sides, then we'd call that shape a triangle, and that would also have 3 angles. A pentagon would have 5 sides with 5 interior angles. Now today we're going to discuss the interior angles of a polygon as well as the exterior angles of a polygon. So to start this lesson, we're going to jot down our key facts. And these key facts are formulae that we are going to use in order to determine the size of interior and exterior angles of a polygon. So if we look at our first one, we have the sum of the interior angles of a polygon is equal to the number of sides minus 2 times 180 degrees. Now the number of sides minus 2 is in brackets, which means that we're going to do that first. So we would first subtract 2 from the number of sides, and then we'd multiply that by 180 degrees. But then that would give us the sum of the interior angles, so all the angles added together on the inside of the shape. We know that the sum of the exterior angles of any polygon is equal to 360 degrees, and to determine the size of an exterior angle of a regular polygon, we would divide that 360 degrees by n, or by the number of sides. At each vertex or at each corner, we know that the interior angle plus the exterior angle is equal to 180 degrees. Quickly pause this video so that you can jot these down. Alright, good. Moving on. What I want to do in our first worked example is I want to calculate the sum, so the total, of the interior angles of a hexagon. So the first thing that I'm going to do is I'm going to count the number of sides in my hexagon. So if I count the number of sides, I have 1, 2, 3, 4, 5, 6 sides in total. Now, if I have 6 sides, that actually means that n is equal to 6. So I'm able to use the formula that we just jotted down in order to calculate the sum of the interior angles. So the sum is equal to n minus 2 times 180 degrees. Alright, so n is 6, so I have 6 minus 2 times 180 degrees. So 6 minus 2 is 4. Times 180 degrees. So therefore the total, or the sum of the interior angles of a hexagon, comes to 720 degrees in total. So if I were to take angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 of this hexagon, I would get a total of 720 degrees. The next question says calculate the size of one interior angle of a regular hexagon. Alright, so we know that the interior angles of a regular hexagon are equal to 720 degrees. There are 6 sides in a regular hexagon, so we would divide that by 6. 720 divided by 6 means that each angle in a regular hexagon is equal to 120 degrees. The next question says the sum of the interior angles of a polygon is 2,700. So they've given us the sum being 2,700, and it's asking us to calculate the number of sides. So the number of sides means that we're calculating n. In order to calculate n, I'm still going to work with my same formula, which is the sum of the interior angles of a polygon is equal to n minus 2 times 180 degrees. But now they've given us the actual sum. They gave us that value being 2,700. So I'm going to substitute that 2,700 in place of the sum equal to n minus 2 times 180 degrees. Now I am trying to isolate this n so that I can solve for that n. In order to solve for that n, I need to get rid of this times 180 degrees on the right hand side. Now the opposite of multiplication is division, which means that I'm going to divide both sides by 180 degrees. So 2,700 degrees divided by 180 is equal to 15. Which is equal to, and now I would carry down my n minus 2. I, however, want to get the n by itself, which means that I'm going to take this minus 2 across, and it's going to become a plus 2, and 15 plus 2 is 17, so therefore n is equal to 17. Now what I'd like you to do is to pause the video and do the your turn section of the worked notes that you have. Alright, now that you've done the your turn section, you can see that you're working with a pentagon, 5 sides. Your sum of your interior angles should have come to 540 degrees. Each angle is equal to 108 degrees. And question number C, the sum of the interior angles is 2160. Calculate the number of sides, and you should get an answer of 14. Alright, the next worked example says calculate the size of an exterior angle of a regular heptagon. So the first thing I'm going to do is I'm going to count the number of sides. 1, 2, 3, 4, 5, 6, 7. So we have 7 sides in a heptagon. So with it being 7 sides, that means that n is therefore equal to 7. If I'm calculating an exterior angle, that means that I'm going to take the 360 degrees and I'm going to divide it by the number of sides, or divide it by n, which is 7, and 360 degrees divided by 7 becomes 51.4 degrees. The thing that we need to note is that an exterior angle is an extension of one of the sides of the shape. So for example, if I'm taking this side over here, I would need to extend that side in order to create an exterior angle. Similarly, if I were to, for example, take this side, it would need to be extended to create an exterior angle. An exterior angle cannot just be a line drawn somehow from the shape and then we say that that is the exterior angle. The exterior angle of a shape has to be the extension of one of the sides. The next question says calculate the size of an exterior angle of a regular 20-sided polygon. So now we have a 20-sided polygon that we are trying to calculate the exterior angle for. So the exterior angle is equal to 360 degrees divided by n. So n is in this case 20. So 360 divided by 20 gives me 18 degrees. Question number C says below you can see part of a regular polygon. How many sides would the complete polygon have? Alright, so now we have part of a regular polygon. We don't know how many sides this polygon has. However, what we were given is the exterior angle being 30 degrees. That means that I can still use my formula for the exterior angle of a polygon. So the exterior angle is equal to 360 degrees divided by n. But now if I look at the question, it says how many sides would the complete polygon have, as in we need to determine our n. We need to calculate our n. So we have the exterior angle. The exterior angle was given to us as 30 degrees. The 360 degrees is a known, which means that we can just calculate the n. So if I substitute in my values, I have 30 degrees for my exterior angle is equal to, now instead of writing 360 degrees divided by n, I'm going to say 360 degrees over n so that I can work with it as a fraction. And what I'm going to do is I'm going to create a fraction with the 30 as well. Because now to solve, I can take the 1 from the denominator of the first fraction, multiply it with the 360, and I can take the n from the bottom of the second fraction and I can multiply it with the 30 degrees at the top. So 30 times n gives me 30n equal to 360 degrees times 1 is 360 degrees. But I don't want 30n, I want n by itself. So I can divide both sides by 30. So therefore 30n divided by 30 is n is equal to 360 degrees divided by 30 is 12. Now what I'd like you to do is I'd like you to pause the video and to try the your turn section in your notes. Alright, having done that, you can see that the answers are now up, that you have 8 sides in the octagon, the exterior angle of an octagon is equal to 45 degrees. The exterior angle of a regular 18-sided polygon would be 20 degrees. And how many sides would the complete polygon have if the exterior angle was 36 degrees and n would be 10? 4 of the angles of a pentagon are 97, 114, 127, and 84 degrees. Work out the size of the fifth angle. So we want to work out the size of this fifth angle. So I'm going to call the fifth angle x. I could have called it x, y, a, b, doesn't matter. Now I have a pentagon. So I know that a pentagon has 5 sides, 5 angles. So what I could do is I could start by just determining the sum of the interior angles of a pentagon. So the sum would be equal to n minus 2 times 180 degrees. So that is equal to, a pentagon has 5 sides, 5 minus 2 times 180 degrees. So that is equal to 540 degrees. Alright, so now what that means is that all 5 of those angles added together need to total 540 degrees. I have 4 out of the 5 angles, so I'm just trying to determine the fifth angle. So I know that x plus the 84 plus the 127 plus the 114 plus the 97 would equal 540 degrees. The 540 I got from there. Alright, so if I add my like terms, I'll have x, 84, 127, 114, and 97 gives me 422 degrees equal to 540 degrees. So to get the x alone, I would take the 422 across, so I'd have x equal to 540 degrees minus 422 degrees. So therefore, x would be equal to 118 degrees. If I look at the next question, I have work out the size of each exterior angle of a regular polygon with 15 sides. So now I have a regular polygon with 15 sides and I want to determine the exterior angle. So we know that the exterior angle is equal to 360 degrees divided by n, and n is the number of sides. So that means that it will be 360 degrees divided by the 15. So the exterior angle would equal 24 degrees. The next question says each exterior angle of a regular polygon is 15 degrees. So I have the exterior angles, and the question is saying how many sides does it have? So that means that I am trying to determine n. So in order to determine n, I'm going to use the information that they've given us, which is the exterior angle. So I know that my formula is that the exterior angle is equal to 360 degrees divided by n. So n is what I'm trying to calculate or determine. So the exterior angle is what they've given us, which is 15 degrees. And that is equal to, I'm going to put the 360 degrees over the n so that I'm able to multiply or solve. So I'm going to put the 15 over 1. So what I can do now is I can take this 1 from the bottom and multiply it with the 360 on the top. And I can take this n from the bottom and I can multiply it with the 15 at the top. So 15 times n gives me 15n equal to 360 degrees times 1, which is 360 degrees. But I don't want 15n, I want n by itself, so I'm going to divide both sides by 15. 15n divided by 15 gives me n equal to 360 degrees divided by 15 gives me 24 sides. Alright, if I have the diagram below showing that 3 identical regular pentagons are joined together, work out the value of y. If I look at y over here, y is not the exterior angle of this pentagon, because remember, the exterior angle of a pentagon or of any shape is an extension of one of the sides. So in order to determine or calculate the value of y, I'm going to have to do something else. So if I look over here, I can actually see that I have a circular shape, or I have angles around a point. Now, these angles around the point consist of 3 interior angles of these 3 respective pentagons. So I have all 3 of those angles, and they're the interior angles of a pentagon. Now, I would be able to recalculate the interior angles of a pentagon. However, we have done it in the previous examples. So we know that the interior angle of a pentagon is actually equal to 108 degrees. All right, so this interior angle of the pentagon is from the previous question, so you can always just rewind to check how to determine that. So to work out the value of y, we could work with angles around a point. So I know that each of these angles in the pentagon is actually equal to 108 degrees. So the angles that I have around this point over here, I have 4 angles, of which I know the value of 3 of them, and I'm just looking for the y, which means that I could add all of these together. So I could say that y plus the 108 degrees plus the other 108 degrees plus the third 108 degrees needs to total 360 degrees. Why? Because it's angles around a point. Alright, so if I were to add the 108 degrees together, I would have y plus 108 plus 108 plus 108, which is 324 degrees, equal to 360 degrees. So to get the y by itself, I would subtract 324 degrees from both sides. So y would equal to 360 degrees minus 324 degrees, which is 36 degrees. In the last example, we have the diagram showing 2 congruent regular pentagons and part of a regular n-sided polygon. So this n-sided polygon means that we don't know how many sides it has. 2 sides of each of the regular pentagons and 2 sides of A meet at the point P. Calculate the value of n and show you're working clearly. What we have is, in these 2 pentagons, we have a pentagon over here and we have a pentagon over here. And in each of these pentagons, I know that the interior angles of a pentagon is equal to 108 degrees. Alright, so I have those 2 angles touching each other being 108 degrees. I would therefore be able to determine this value or this angle over here because I have a point, and these would be classified as angles around a point. So I have 3 angles and they're all around the same point, which means that I know that the sum of those 3 angles needs to total 360 degrees. I have the 2 of the angles. I have the 108 degrees from each of the pentagons, which means that I will therefore be able to determine or calculate this third angle. Once I've determined the interior angle, then what I will be able to do is I will be able to say, all right, well, if I have this interior angle over here and I were to extend this blue line over here, then I would be able to determine this exterior angle. And if I were to determine that exterior angle, then I'd be able to use my formula to determine how many sides this polygon has. But I'm going to do it step by step. So the first thing I'm going to acknowledge is that I have those 2 interior angles being 108 degrees each. So if I were to call this angle over here, I want to call this angle x. Okay? So that would mean that I would have x plus 108 degrees plus 108 degrees equal to 360 degrees. Why? Because it's angles around a point. So that would mean that x plus 216 degrees is equal to 360 degrees. So I would subtract 216 degrees from both sides. So I'd have x equal to 360 minus 216, which is 144 degrees. So that means that I have the angle being 144 degrees. Now, if I erase my diagram, this 144, I would therefore be able to put onto my diagram being 144 degrees. If I were to extend this line of the unknown polygon, then that means that I would be creating this angle over here, which is the exterior angle. So I would have been able to create the exterior angle. And I'll be able to determine the size of that exterior angle by using angles on a straight line. So I would say, therefore, that the exterior angle would equal 180 degrees minus the 144 degrees. Why? Because it's angles on a straight line. So it would equal 36 degrees. But then this 36 degrees that I have now is the exterior angle of this unknown polygon. So I know that the exterior angle of a polygon is equal to 360 degrees divided by n. But I don't know what n is, but what I do know is I know that the exterior angle of this polygon is 36 degrees. So that means that the 36 degrees would equal 360 degrees. Instead of divided by n, I'm going to put it over n. So I'm going to put the 36 over 1. So that I can cross multiply, I'm going to take this 1 from the bottom. I'm going to multiply it with the 360 at the top. I'm going to take the n from the bottom and I'm going to multiply it with the 36 at the top. So 36 times n gives me 36n equal to 360 times 1, which is 360 degrees. But I don't want 36n, I want n by itself, which means that I'm going to divide both sides by 36. So 36n divided by 36 gives me n is equal to 360 degrees divided by 36, which is 10